Hi there, my name is El-Rukby. This is part 2 of the end-to-end big data demo. In part 1, we described the overall series scenario of a national book club site that enables its members to provide comments and ratings on the books they have read, and then in turn would provide them with recommendations on what books to read based on their taste and the taste of other people who are similar. In that part, we went over the technology implementations you see here. Now, in part 2, we'll focus mainly on two things. The first one is data acquisition by different means, because it is a big part of what data scientists and teams need to do to build more accurate models. Some of the methods we'll go over are screen scraping, accessing APIs such as Twitter, and importing data from relational databases using Sqoop. The second thing we'll focus on is an implementation of TF-IDF, or term frequency inverse document frequency, for doing sentiment analysis on some of the tweets that we get, or the Twitter feeds that we get. So let's have the demo. The way I will go over this demo will be as follows. First, I will use screen scraping to acquire some reviews and ratings. Then I will implement TF-IDF to build the model. Then I will use that model in a program to evaluate some of the reviews as to whether they are positive or negative or neutral. In the second part, I'll be using the Twitter API to get tweets about a book. Then I will evaluate some of those tweets using the same program and model. And then in the third part of the demo, I'll basically demo using Sqoop to import book rating data from a MySQL database into HDFS. And this way, we would conclude the demo in episode 2. So when we talk about screen scraping, this is not something new. As you know, there are many online vendors where you can go online and buy books. And when we talk about screen scraping, it's basically you need to have a very good understanding of the structure of the web page, because what you are doing is that you are programmatically acquiring the web page and the text within it, and then you are parsing that text to get the specific data that you want. So there are, as we were talking, there are a number of vendors. We have like Barnes & Noble, Amazon, O'Reilly, and there is so some of these vendors, they have, as we were talking about, they have their own structure. And then another thing just need to note is that each one of them, or most of them, they have their own policies regarding screen scraping, so you need to be aware of that and comply with it. What we are doing here is more for educational purposes. Now, in a typical review, we'd have the ratings and the rating, and then it would have like a header for the rating, and then there is the actual text of the review itself. And this is, these are things that we are interested in acquiring. So another thing I wanted to note is that different, obviously some books are very popular and some other books are less popular. And of course, like technical books, a book on Hadoop or Mahout will not be read by as many people as, people reading a famous novel or like a famous political book on the bestseller list. So I'm intentionally here in my demo starting with a technical book where we would have a smaller number of reviews, so we can save some time. But I will run the script again against like John Grisham's The Racketeer, which we talked about, which we mentioned in the earlier episode. And but I'll pause the recording at some point so we can save some time. So let's have a look at the program. So this is basically, it's a Python program. It has the capability of acquiring the book reviews and then either generate them as a flat, like delimited text, or as JSON. You just change it here. In the case of JSON, I left this program. This is the output folder. Once we run the program, it will output the reviews it gets into a file for a specific book, and the name of the file will be the ISBN of the file. And so this is, in the case it was JSON, but for what I will be demoing, it will not be JSON. It will be flat text basically, or like delimited text, space delimited, or tab delimited. I'm sorry. Now the file, the program reads the book list that it will need to go and fetch from this file here, which has the URL of the site and the ISBN and whatever that is specific to the site to be able to get the specific books that you want. And as I said, when we are done, after we run the program, it will generate a file here. So we should see a second file now once we run the program. Okay, so I'm gonna run the program, looking for getting reviews on Hadoop, the definitive guide. So what you see here is that it's outputting, it's parsing basically. Started with the 5-star rating, and then the 4-star rating, now 3-star rating, and then the 1-star rating. And then if we look here, you see that it generated the file, and here it is. So this is the part demoing that we will doing screen scraping to get book reviews online. I'm gonna pause, and then I'll return when I'm ready to run it against the rack tier by John Grisham. Okay, so this is the rack tier. As you see, there are a lot more reviews on it, and I've already entered the ISBN into the book list, and so I'm gonna run it against the rack tier. And it started getting data, and while it's getting the data, I'll have you have a look at the actual code itself. As you can see, it's a lot of parsing and looking for specific characters. The way I did it, it's like each one person has their own way of doing screen scraping. So the way I did it there is, first cut and then a second cut, and to minimize the complexity. But as you can see, it's not a very complex program actually. So still, now it moved into the 4-star rating. It would be interesting. You start seeing, just by having a look at in this area, you can start seeing the differences in the words that are, between 5 and 4 there isn't much, but once you get into difference between 5 and 1, obviously. So I'm gonna pause the recording at this point, and then we'll resume later. So now we are in the 1-star rating, and you can see the words are very different than the 5-star rating. I saw the word terrible more than one time already, and scammed, and skip this one. Overrated, boring, disappointed. Yep, more than one time, disappointed. Okay, so it's done, and here we go. We will refresh, and you can see this book, John Grisham. Right, so 4-star, 3-star, 2-star. So this is the part of the demo, basically, where we acquire reviews and ratings online programmatically, and we put them into files in a specific format that will help us to parse them, and to also help us to create the TF-IDF model, which is the next step. The next step in the process is that we will take the words in the reviews, and then we will, based on the ratings that they occur in, so this is like rating 5, this is the word excellent here. So this word excellent, each one of these words actually, because it happened to occur in a rating of 5, which is considered favorable, it will go into this file, favorable, in this location. And then words that are unfavorable, if you go down here and say like poorly, right, it will go into this file. And then words that appear in where the rating is 3, then they would go into the neutral, because this is to simplify the processing, and what we are just trying to determine here is, when we ask the program for evaluating text, is it really positive, negative, or neutral, basically favorable, unfavorable, or neutral. So for doing so, there is this Java program that basically will take the book ID, and it will read the information that's in here, and so you see here it's pointing to it, and then it will, as we said, it will output into one of these files for each one of the words. Okay, so let's try it. So I know that it will ask me for the ISBN, so this is ISBN or the book, and then if we come here, run it, to the book ID, execute, and it's done. So notice performance is pretty good. So now if we go into one of these files, you see the data, all the words are now in one of these files. Okay, so now let's run the program against the Racketeer. It will ask me for the ISBN, so copy it from here. And then execute, and it's done. So if we look, let's say the unfavorable, now you see it's a lot more. If you go to the bottom, like you will see more of that. You know, here it says like the word Grisham. So now we have basically taken the words that we got in the reviews, and then we split them according to the rating into whether they tend to be favorable, like they appeared in a favorable context, unfavorable context, or neutral. The next thing is then we will run them against TF-IDF implementation to generate the model. And so we have it here, and I'll go over that now in a little bit more detail. So next we'll have an implementation of term frequency inverse document frequency. And as we said that we parsed all the words that were in the ratings in the reviews into one of three documents, either favorable, neutral, or unfavorable. So you see here the unfavorable, it's a compilation of all the words from the reviews that were had a rating of 2 or 1. These are words that appeared in reviews that had a rating of 3, and these are words in reviews that had a rating of 5 or 4. The implementation, the TF-IDF implementation, is an iterative implementation. Before I talk about that, I just want to mention that typically there are some things that need to be done to make the model more accurate, such as stemming, basically like transforming words that have a similar meaning, whether like plurals into and different types, whether you say cat or kittens, and the other thing also like filtering out stop words, and things like also like dealing with case sensitivity, such as transforming everything to lowercase and so on. Not all of these are implemented here, but there is enough to demonstrate the concept. So when we run it, this program, as I was talking, that it will be it's an iterative thing, because we would need to basically calculate first, the term frequency, count how many times a given term occurs in a document. Then we'd calculate the word count in documents, basically like count the total number of terms in a document, then calculate the total number of documents. And so there is like a number, and then get the inverse of that. And then we would calculate TF-IDF by multiplying, the calculation of the term frequency times the inverse document frequency. So if we look here in the reducer, this is the basically the driver for the MapReduce, and then it has also the final MapReduce. So in the reducer here, there is the calculation of the term frequency, and then the inverse document frequency, and then the calculation of TF-IDF. So when I run this, it will basically execute this one, and then it will execute this. It will execute this one, then this one, and then it will execute the MapReduce that's embedded here. Now, and then it will generate folders here accordingly. So let's run it and see how it goes. So the first folder now appeared. It's word frequency. Now that folder became an input to the second job also, and we are calculating the word counts. Okay, so it's done, and then you see here there is an output folder. So if we have a look at the first one, as you see here, the word, each word, it appeared in, let's say, in abandoned appeared in unfavorable once, and abandons in unfavorable 1. So that aspect I was talking about of stemming, I did not implement that. But as you see here, is that you can see that it's implement like the count of the words, whether they are in favorable or unfavorable and neutral. And then here you have, as you see here, this is favorable, right? So the number of words that are in favorable, actually it's been counted to 31,388. And if you go down, we go down here to get to the unfavorable. Like neutral, it's 19,876 words, and platform is appeared once. And then we get to unfavorable, there is 30,299, and the word suspend appeared 7 times. And then if we look here in the reducer, as we were saying, that this is basically after we generated all of that and we calculate TF-IDF. Now what we do is that if the word appeared in favorable, we make it positive, basically. We make that ratio positive. If it appeared in unfavorable, we make it negative, and if it appeared in neutral, just multiply it by 0. So this is just some groundwork for the next program that will basically evaluate whether a word, a sentence, is positive or negative overall. Because what it will do is it will add the value of the word, the total value of or like the sum of the values of the words in the sentence. So to make that clearer here, the output, actual output, is what we end up with out of this implementation here is each word has a value, and some values are positive, some values are negative. And that's basically based on their appearance and relative appearance in favorable context or unfavorable context. So when we add them together, then you will get a number, and that number is again, if it's a positive number, then it's favorable. If it's a negative number, it's unfavorable. Okay, so this is the demo of the implementation of TF-IDF, and with that, then we would have we can try some words based on that. Try the program, which will be next. So this is a simple Java program that basically, as you see, it creates a map, a hash table of the words and their values, whether like a key value pair from this, and then it will ask you. You enter a comment, and then it will look for these words, and see, well, each word what value it has, and then it will add them, and then based on that it will tell you that it's positive or negative. So if we try it, so if I type something, as you see, it says favorable, and then if I say waste of time, it's unfavorable. So let's try some other wordings. So I enjoyed reading it, favorable. What a horrible book, unfavorable. So one thing I wanted to note, that this is, as I noted earlier, this is a little bit of a simpler implementation, and it doesn't catch yet things where people use words that are, for example, they say this is not the best, right? So there can be more improvements implemented, but I think just the main idea here is just to give you a feel for what is typically done. The next thing is we'll try to do is to leverage the Twitter REST API, where we pass it a book title, and we get some of the tweets that people are tweeting about it. And so if you see here, there is this program, query Twitter, and I'm doing this in the CentOS Linux machine because I have a library that abstracts the Twitter API already installed here. Now, and the other thing is, I'll show you the content of this file. So this is it, and this is the library I'm talking about, 2EP. And the reason I'm showing it this way is because I don't want you to see my specific information with the account with Twitter. This is information that you need to get for yourself. You can just go to the Twitter API portal and get an account, and you'll be assigned these keys, and then you can use them. And then with this library, what as you can see, the implementation is pretty easy, pretty simple. It handles OAuth authentication, and now what we will be looking for, as I have, this is just for the demo. This is the name of the book. There's a book, and then there's it became a movie, and it's a popular movie, and it's hard coded into the script. So. But in a real implementation, basically, it would be that whatever we get, then as you see here, there is a program that will process the tweets. But for the demo, we'll just get the tweets, basically execute this, and then we'll take some of the tweets and use them against the program where we would evaluate whether they are positive or negative. So let's try that. And when I run it, so I'm not going to pass any parameters. So this is what we get back, and now let's have a look. See, so you can see the comments here. So let's take this one, for example. And try it. So what the person is saying, I wish I saw Divergent in the movie theater reading the book. It's so good. And as you can see, it's saying it's favorable. So with that, we demonstrated the use of the Twitter API and accessing, getting the Twitter feeds, and then processing some of the tweets, like a tweet. And in reality, as I said, we would programmatically process the tweets using the similar code. And we need to parse, of course. There is some parsing, because not all the tweets are actually comments. Okay. The last part of the demo is using Sqoop to import data from a relational database into HDFS in Hadoop. In this case, the relational database is MySQL. So the first thing a user would need to do is to set up the JDBC MySQL driver, and these are basically the instructions for that. So you can download the latest one. You need to have an Oracle account for that, and then untar it and copy it into the appropriate location for the Hadoop distribution that you have. This is the location for the Cloudera distribution. Okay, so I have that already set up on the CentOS Linux machine, so I'm going to connect to it. Okay, I'm in, and the first thing is we'll log into a specific table on the MySQL database server. So and this is a table. It's an IP2 location. This is the database, basically. And if we show tables, so now we have this table. Now this table is a table that can be used to help website owners correlate, customize basically the services they provide based on where the users are coming from, and have some statistical information on what countries or what locations or what parts of countries and what cities do the users come from. So let's have see the count for this table, and this count will be important because after we do this Sqoop, copying of the data from Sqoop into HDFS, you will see that it's the same count. So do a select count. Okay, so this is the number 1,860,188. So keep this number in mind. And then let's have a look at some of the data that's inside this table, some of the records. So as you can see, we have here IPs and the association with latitude and longitude and zip code and time zone and region and city. Okay, so now let's get out of MySQL and go into HDFS to navigate the structure. One way of looking at HDFS is to do that in Hue. And so for the Cloudera user, you can see there are these folders. And as you can see here, when we create the IP2 location, it will be between those two. So it's not there right now. So let's create it. Let's have a look here first also. If you look in Hadoop, if we list the same folders and files first. So these are the same files that we were looking at, and for the same directories and files. Now let's make the directory for IP2 location. Okay, so if we view now here, you see it here. And if we click, it's empty. Okay, so let's now try Sqoop. So I'm gonna copy and paste the command, save some time. Let me do a clear first. So here we are. So what you see here, you start with the Sqoop command. You can list the databases. This is the connection information. You pass it the credentials. So this lists the databases, and if you want to list the tables within this database, we can use the list tables command. So here it is. Let's execute. And as you see, this is the table. Okay, so now let's execute the command for importing this table data into HDFS. And when we are done, we should see that it's the same total number of records. So again, here you see Sqoop, import. We give it the connection to the source using the JDBC driver, and the credentials. And then we give it the connection to the destination here. Okay, so let's start executing. And when it executes, you'll see it's basically a MapReduce job, and it takes a little bit of time, but not too long. Okay. Okay, so it's done, and as you can see, the total number of records is the same, 1,860,188 records. So if we have a look now in HDFS, we'll go here into IP location. This is the table that's been copied, and these are the files. If we look at it, this is one of them. This is the data. Okay, so this concludes our demo using Sqoop to import data from a relational database, which was MySQL in this example, into an HDFS storage. So that was the conclusion of the demo in part 2. I hope that you have found it to be useful. In part 3, we will go into the items listed here: Lambda architecture, real-time stream analysis using Spark, recommendation engine using Mahout, and some discussion of some of the algorithms and correlations, and also we'll have a look at some implementations in the cloud, especially in Amazon Web Services. Thank you. This is it.